Hello guys, with the name of God Ram Ram, I am Kumar K. Before we start this session, I want to tell you that whoever is watching this video, I love you. I hope you get the right guidance, right mindset, right environment in life, which can make you propel and prosper towards the best kind of growth in life. Okay? Because those things are really, really important. So the first problem which we are going to do is Codeforces F, right? Round 1029 Division 3 F problem. It's a very interesting problem on tree. So whoever is new to, my videos, I will like to tell you that the link to this prerequisite course must be attached in the document in the description. So please do my prerequisite premium course for DSA plus OA plus CP. It will hardly take 5 to 10 days to complete this course. It's a mini. It's a very mini version of our actual 800 to 1000 hour course. But if you do it, I can guarantee that you can, at least become able to understand, the solutions even for the hardest of the hardest problems of DSA in OACP and FANGAM interviews. So make sure you complete this course. And if you are watching this video, I assume that you have completed the tree section from this course. Okay. Because when I'm teaching such a hard Codeforces F problem, I assume that the person watching this video has gone through my tree course. They know everything about trees, they know about BFS, DFS, and all the standard tricks, and many more special variations which I have taught with so much love in the course. So make sure you check them out. So guys, now while teaching this video, I assume you guys know most of the things about trees. Okay. So what is the question trying to tell us? Question is saying that given a tree, assign the value 1 or 2 to each node such that all subtree sums are unique. Assume the tree is rooted at node 1. 5 times R, which is Ram, 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 Ram. Okay. So, what I mean to say is like, how does a tree look like? So, tree looks like this, right? This is a tree. Let's say this is node 1, this is node 2, this is node 3, node 4, node 5. The topmost node is called as the root node. Okay. And you can say that the node 3 is child of node 1, node 2 is child of node 1, and things like that. You can say root node is nothing but the node at the topmost level of the tree. You can say that the node number 1 in this case is the root of the tree, but each node can have some value, right? So let us say that the values are like this: 5, then there is this 4, there is this 3, then there is this 8, and then there is this 1. Okay, let's say the values like these are there. Okay. So what I mean to say for you people is that they are saying that consider the subtree sum of each node. So what is sum of 1? Sum of 1 means nothing but sum of all the nodes which are below node number 1 and including the node 1. So sum of 1 is denoted by this red mark. Sum of 1 will include all the nodes below node 1 and the node 1 itself. So what it is: 5 plus 4 plus 3 plus 8 plus 1, 9, 12, 3, 12, 21. So sum of 1, sum of this whole part is 21. So sum of 1 is 21. Now what is sum of 2? Sum of 2 means you have to consider everything from node 2 and all the nodes coming below node 2. So if you consider this subtree of node 2, only this much part is there, right? So value of node 2 is 4. So sum of 2 is nothing but what? 4. Okay. Sum of 2 is 4. Now, like, you can pause this meeting for a minute. You can pause this meeting for a minute and write in your book, paper, pen, what is sum of 3? Sum of 3 means, guys, the subtree, the tree which starts at node number 3. If you only consider that part of the tree, sum of 3 means consider node 3 and all the nodes below node 3. So this part they are talking about. If you consider this part, what is the sum? Sum is 3, 4, 5, which is node 3, node 4, node 5. And the values are 3 plus 8 plus 1. So which is what? 9, 10, 11, 12. So sum of 3 is 12. And similarly, guys, like I hope you understand that sum of 4 is like only this part, right? Which is sum of 4, this subtree. So it is 8. And sum of 5 is 1. So guys, you can say that these all are called as subtree sum. This is called as subtree rooted at node 1. This is called as what? This is called as subtree of the original tree rooted at node 2. Rooted at node 2. That is the definition. So the question is saying that all the subtree sums should be unique. You can read it here. Ram Ram. So what I mean to say is that they are saying that this all the subtree sums are unique, should be unique. So कहने का मतलब ये है कि जो भी आपका ट्री है ना, उसके जितने भी ये सब ट्री के सम आएंगे ना, ये सब डिफरेंट होने चाहिए. सी 21 इज डिफरेंट फ्रॉम 4, 4 इज डिफरेंट फ्रॉम 12, 12 is different from 8, 8 is different from 1. None of the subtree sum should repeat, or else it will create a problem. So like there are many possible subtrees. I will ask you and I will check your knowledge. Can you tell me that is the given tree valid tree or not as per the question? So node number 1, 2, then 3, then 4. Let's say this is 2, this is 1, this is 2, this is 1. So what will be sum of 1? Like sum of 1, obviously node 1 is the root node. So sum of 1 means if you consider all the nodes, what is their sum? 2, 3, 4, 4, 6. 6. What is the sum of 2? Only this much part, right? So sum of 2 is 2. What is sum of 3? Sum of 3 is, well, 2 plus 1, 3. What is sum of 4? Sum of 4. So this node is 4. So sum of 4 is 2. Is this valid? I have calculated all the subtree sums. Are they valid? No. Why? This 2, the sum is getting repeated. Repetition is not allowed. Guys, hopefully you understood that repetition is not allowed. You just need to get very deep into the problem. Immersion, deep immersion is the solution to all most of the problems of your life. You can even say all problems if you want to. So hopefully baby or bro you are enjoying it, right? Yeah. So ये तो valid नहीं है. तो now the question is that I will give you any tree. I will give you any tree. With the name of God Ram Ram, I will give you any tree. And you have to tell me how many ways are there. How many ways are there to make it a valid tree? Valid tree. Make it a valid tree. Valid tree is which kind of tree? The tree which has all distinct or unique subtree sums. Distinct और unique subtree sums मतलब तुम्हारा जो भी ट्री है ना उसके अंदर हर सब ट्री का सम अलग आना चाहिए, सेम नहीं आना चाहिए. अगर अलग आ रहा है मतलब तुमने वैलिड ट्री बना लिया. पूछ रहे कितने तरीके हैं वैलिड ट्री बनाने के. They're asking you how many ways are there to create a valid tree, bro. You can just bask in the glory and relax. So now you can read the question. They are saying that the tree is given to you. You have to yourself assign a value 1 or 2 to each node, such that all subtree sums are unique. Assume the tree to be rooted at node 1. Now, how many ways are there to create a valid tree? Ram Ram. Ram 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 Ram. So, guys, it's difficult to decide. Like, if I give you any tree, how will you know what to do? Like, let's say I give you a tree like this. You can assign either one or two here. You can either assign 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 one or two here. How will you know how many ways are there such that all the subtree sums will be unique? Such a difficult problem to think about, right? Well, no. Let's try to take the easy case. Like in my course and training also, I've taught it so many times that lovely students try to take the easy case. So let's take a linear tree. Can you solve the question for a linear tree? Linear tree is nothing but an array. So this node, then this node, this node. So this is a linear tree. What is the answer for this? What will you assign here? What numbers can you assign? You can only assign one or two. It is given in the question also. You would like to give Yusuf an array A of length n where each AI is can be either one or two. So basically you have to assign these values and you just have to make sure that everything is 1 or 2. Very, very important. Take proper care of your LinkedIn profile always, okay? So this is also we don't know how to solve. So let's take the easiest case. What if there is only a single node? What you can do? You can either give a value 1 or 2. Both are valid. Why? If there is only single node in the tree and the value is 1, yeah, it's correct. The subtree sum is 1, correct. If there is only one node and you give it value 2, then also it's correct. The subtree sum, there is only one subtree sum is 2. So there are two ways. For one node, there are two ways. So the number of ways to assign 1 or 2 to a single node is two ways. What if I give you a slightly difficult problem and I tell you, tell me the answer for this tree? I will say there are four ways. Which are those four ways? You can give one here, or you can give one here, two here. This is node 1, this is node 1, this is node 2, this is node 1, this is node 2. Why are these ways valid? Well, in this, if you create this tree, here the subtree sum is 1, here the subtree sum is 2. Both are unique sums, so this is valid. Why is this valid? Here the subtree sum is 2, and if you consider this subtree, the sum is 3. 2 and 3 are different. This is valid. Let's create one more case. You give 2 here and 1 here. This is also valid. Why? This 2 is also valid. Why? This is the subtree. If you for this tree, this subtree has sum 2, and this subtree will have the sum of 4, and 4 and 2 are different. These sums are different, then everything is done, going good. So you can also feel it and I can also feel it. So this is also valid, by the way. This assignment is also valid. Why? Here the subtree sum is 1, and here the subtree sum of this node rooted at node 1 is 3. Why? 2 plus 1, 3. So guys, there are 4 valid assignments. How many valid assignments? 4 valid assignment. One way, second way, third way, fourth way. So it is very easy for your brain to understand that for a linear tree, you can, at the first node you can put 1 or 2. At the second node also you can put 1 or 2. So there are two options here, two options here. So 2 multiplied by 2, 4 is the answer. Now why is this working, guys? What is the theoretical proof? The proof is pretty simple. Let's say you put a value of 1 year. Okay. Now here you, if you put 1 or 2, both will be valid. Why? Because this sum is what? 1. Now this sum, let's call it as sum 2. Sum 2 will always be greater than the original sum. Let's say the below node value was 1. Now you are adding one more positive value here. Let's say this is 1 and here you are adding 1 or 2. So this sum will surely be bigger than this sum ना. नीचे वाले नोड का अगर वैल्यू 1 है और अगर ऊपर वाले का वैल्यू 1 या 2 कुछ भी डालो तो ऊपर वाले का सब ट्री सम तो नीचे वाले के सब ट्री सम से ज्यादा ही आएगा ना. ज्यादा आएगा. इट because sum 2 is greater than sum, it can be proved that sum 2 is not equal to sum. That's what you want. You wanted non-equal subtree sums. And the same happens if you put at the bottom node 2. Hence proved you are correct. Like if you try to put 2 at the bottom node, let's say you try to put 2 at the bottom node, then also it's correct. Why? This subtree sum will be 2. And here if I put 1 or 2, what will be the answer? Answer will be either 2 plus 1. If I take 2 here and 1 here, the answer will be 2 plus 1. And if I take another 2 here, the answer will be 2 plus 2. Both these values are bigger than this original 2. So the subtree sums are always different. You take 1 or 2. That's why all the nodes can have the two distinct values if the tree is linear. So guys, we have solved the problem for a linear tree. What is the solution? You want unique subtree sums beta? No problem, no problem. The solution is pretty darn simple. So what I mean to say to you people is that you can just chillax, relax and enjoy the life, baby. So guys, if the linear tree is given to you, linear tree has only one leaf. Leaf ka matlab the bottommost node. See, only one leaf is there. The node which has only one parent and 0 children is called as a leaf. So only one leaf is there. So for the tree, linear tree with one leaf, what is the answer? Answer is 2 raised to 5. Just calculate the length of this chain. There are 5 nodes, right? 2 options here, 2 options here, 2 options here, 2 here, 2 here. Hopefully you understand the basics of combinatorics. Here you can put 1 or 2. Here you can put 1 or 2. Here you can put 1 or 2, 1 or 2, 1 or 2. So you will multiply all the combinations, right? Of assigning the 1 and 2 values. It will become 2 raised to 5. In case you don't know about combinatorics, you can just go to my prerequisite course and complete the mathematics course given there. It will make you understand कि हमने multiply क्यों किया. Like तुमको छोटे example से समझ आ ही जाना चाहिए. When there were only 2 nodes like this, you took 1 2 here, 1 2 here. So 2 options here, 2 options here. So what was the answer? These 2 multiplied by these 2, 4 assignments, right? क्योंकि यहाँ पर एक या दो आ सकता है, यहाँ पर एक या दो आ सकता है. तो सारे कॉम्बिनेशंस मिलाएंगे तो क्या होगा? ये 1 के ये 2 कॉम्बिनेशंस, ये 2 के ये 2 कॉम्बिनेशंस. तो ये 2 और ये 2 को मल्टीप्लाई करना पड़ेगा तो टोटल कॉम्बिनेशंस आएंगे. तो ऐसे ही अगर चेन बहुत बड़ा है, then the answer is pretty simple, right? So for a linear chain, guys, it's written here. For a linear tree, let us say that the length of that chain is L1. So answer is power of 2 raised to L1. Done. But guys, what if the tree has more than 2 leaves? Then what would be the answer? Let's say the tree is like this. This is the root node. How many leaves are there? This is first leaf, leaf number 1. This is second leaf. This is third leaf. My claim is that if there are greater than 3 leaves, answer is not possible. Can anyone tell me why the answer is not possible? If there are 3 leaves or more than 3 leaves. इस tree में कितने पत्तियां है? 1 leaf, second leaf, third leaf. Leaf means a node which has no children. This node cannot be a leaf, it has three children. This node also has a child. Child means the node directly connected to your bottom. पर इनके कोई चाइल्ड नहीं है, देखो ना, इसका कोई बच्चा है, इसका कोई बच्चा है नहीं. Does this node has any child? No. Does this node has any child? No. So there are three leaves. This cannot be solved. Why? Because you can only assign one or two. Now, let's say you assign a 1 year. Let's say you assign a 2 year. Now here you will have to put one or two. You have no other option. You cannot put 3 year. ये नोड को आपने 1 असाइन किया. टू दिस नोड यू असाइन 1. टू दिस नोड यू असाइन 2. To this node you need to assign 1 or 2. You cannot assign 3 because it is written in the question that you can assign only 1 or 2. So if you are trying to assign the values to the leaves, first leaf ko you gave 1, this leaf ko you gave 2, and this leaf you again have to give 1 or 2. Let's say you give 1 and the problem is failed. Why? Because this subtree sum will have 1 sum, this subtree sum will have 2, and this subtree sum will have 1 again, 1 getting repeated 2 times. So if you have greater than equal to 3 leaves, now there is no way to solve the question. For example, like this is first leaf, second leaf, third leaf, L1, L2, L3. So there are 3 leaves, you cannot solve the question. I put 1 here, I put 2 here. Here I need to assign 1 or 2. What can I do? Let's try to put a 2. You failed. Why? This subtree sum has 1. This subtree sum has 2. This subtree sum has 2. 2 cannot come like... The subtree sum 2 cannot come multiple times. Every subtree sum should come one time only. यहाँ पर लीफ इतनी ज्यादा है कि 1 2 रिपीट हो जा रहा है. रिपीट नहीं होना चाहिए. So just by the observation of leaves, this question becomes so easy, right? So enjoyable, like really so enjoyable. The deep understanding. Ha ha ha. Now, correct. Ram ram. So guys, you understood that if the tree has only one leaf, okay, let's say the tree has one leaf, then what is the solution? Node 1, node 2, node 3, node 4, node 5. This is your one leaf, L1. In this case, just calculate the length of this chain using BFS or DFS. Answer is 2 raised to L1, where 2 raised to 5. What if the tree has greater than equal to 3 leaves? It has 3 leaves or more than 3 leaves. Then the answer is 0. There is no way to assign the values. Why? Because it has greater than 3 leaves. If a tree has 3 leaves or more leaves, you cannot solve the question. Why? You will give 1 value here, you will give 2 value here, and now again it will repeat. You have to give 1 or 2 here, and this one subtree sum will match this one tree, and this 2 subtree sum will match this subtree sum. That's why guys, अगर तुम्हारे ट्री के एक लीफ है तो आंसर है 2 रेज टू लेंथ ऑफ द चेन. और अगर तुम्हारे ट्री के 3 या 3 से ज्यादा लीफ है तो आंसर इज 0. यू कैनॉट असाइन द values to the nodes to generate a valid tree cannot come. So 0 valid tree. And if one leaf, then this. Then guys, which case is left? Sir, what if only 2 leaves are there? This is a very interesting case. So this question we have solved for all types of cases. Okay, like most of the cases we have defined, not solved, but most of the cases we have defined. If there is one leaf, the answer is 2 raised to L1. L1 is the length of the linear chain. If there is 2 leaves, I don't know how to solve, we will see it. If there are greater than equal to 3 leaves, answer is 0. So only this case is pending to be solved. Let's do it. In the exam also, you could have gone through this example and tried to make sense of this. Can you see there are 2 leaves here? Node 1 is the root node. Leaf is 5 and 7. See, 2 leaves are there. Now what will you do? Think about that. Done. Okay. So if there are 2 leaves, guys, it's actually pretty easy. Okay. This is node 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10. Now, which values you will assign and where will you assign? Let's think about that. Very simple. Very simple. मेरी बात एकदम ध्यान से सुनना. Two leaves are there. One leaf is this 8, another leaf is this 10. One leaf is 8 and one leaf is 10. I want you to calculate the length of both the chains. This chain is of how much length? 1, 2, 3, 4, 5. So let's call it as L1. Length of the left chain is 5. What is the length of the right chain? This chain. 2. L2 is 2. So guys, if there are two leaves, now the tree will always be like this only. See, tree will always be like this. Some nodes here, then there will be upside down Y node. Okay. From this intersection, one chain will come. This will be of L1 length. And then from this chain, this node, another chain will come. And this length will be L2. So L1 and L2, done, done. Okay. So L1 and L2 will be there. You can understand. मेरे कहने का मतलब ये है कि अगर ट्री के अंदर अगर दो ही लीफ है ना, तो ट्री हमेशा वाई शेप का दिखेगा. इफ ट्री हैज टू लीव्स ना, it will always look in the upside down Y shape like this and then like this, okay. This will be first leaf and this will be the second leaf. I am saying that let this length be L1 and let this length be L2. L1, L2, I am not assuming them as leaves, just the length of this chain. Okay? And this chain, let's call it as X length. Okay? There are three chains when the tree has two leaves. ये एक चेन हो गई आपकी, ये दूसरी चेन और एक चेन जो स्टार्टिंग से आई थी रूट नोड से. Three chains are there. Let's try to solve it for all the three chains. Done. Okay. So in this case, these are the two chains. You can feel it, I can feel it, everyone can feel it. These are the two chains, all of us can feel it. Now what to do? Okay, let's try to assign some number. Guys, what can we do? We can try to assign 1 here, right? Let's try at this leaf, let's try to put a 1. And in the another leaf, let's try to put a 2. Okay, मैं बोल रहा हूं कि यहां पर 1 डाल देते हैं, यहां पर 2 डाल देते हैं. Can you tell me why can you not put 1 at both the places? Some students might say, sir. Yes, say, sir, I will assign this node as 1 and sir, this node as also 1. This is not allowed. Why? Because then this subtree sum will also be 1 and this subtree sum will also be 1. You will fail. दोनों जगह 1 नहीं डाल सकते बेटा. So I am going to assign the numbers to whole tree. I am starting with the leaves because it's easy to do with the leaves beta. DP on trees, if you realize or remember. So let's try to put, this is the L1 chain, okay, L1 chain. For this chain, let's try to put 1 here. So I put a 1 here and I put a 2 here. Is everything all right? Let's check. This subtree sum is 1. This subtree sum is 2. Both the subtree sums are unique, no problem. So guys, मैं लिख भी दे रहा हूं, ठीक है? I am assigning 1 to the leaf of chain L1 and I am assigning 2 to the leaf of chain L2. So these many things are clear to you. Now what can you do? Think about it. What value can I put at node 7? Can I put a 1 here? No. Why can I not put a 1 here? Well, beta G, If I put a 1 here, what will be the sum of this subtree rooted at node 7? The sum of the subtree will be 1 plus 1, 2, which is not allowed because already this subtree sum is 2. So you cannot put a 1 here. Oh my god, what a revelation. It means you need to forcefully put a 2 here. Watch this on repeat again and again. On node number 7, you cannot put a value 1. You cannot assign the value 1. Why? You cannot assign the value 1 because then the subtree sum of node 7 will be 1 plus 1, 2, which is equal to subtree sum of 10. तो यहां पर तो 2 ही डालना पड़ेगा. So you can say that for L1, which subtree sums have come till now? Subtree sum of 1 and subtree sum of 3 has come. Subtree sum of 1 and subtree sum of 3 has come, okay? For L1, subtree sum of 1 and subtree sum of 3 has come. And for this L2 chain, like this is L2, right? The subtree sum of 2 has come. For L2, the subtree sum of 2 has come, okay? Now guys, what value can you assign here? Can you assign value 1 here? No. Why? If you assign the value 1 here, 1 plus 2, 3. 3 is already a subtree sum here in the L1 chain. You cannot repeat the same sum. So your current sum should be bigger than 3. So you cannot put a 1 here. You need to forcefully put a 2 here. You need to forcefully put a 2 here. Oh my god, oh my god, oh my god. Now this subtree sum of this will become 4, which is unique, which has not come before. So now you can say that the L2 chain is having these subtree sums 2, 4. The L1 chain is having these subtree sums 1, 3. At node number 6, guys, you can see 2 nodes here, 2 nodes here. Now at node number 6, what will you do? Well, at node number 6, lovely beta G, at node number 6, can I put a value 1? Well. L1 chain is what? 1 and 3. So if node number 6, if I put a 1 here, 1 will be added to this 3 now because subtree sum of node 7 is 3. So if I add 1, subtree sum of node 6 will become 4, which is not allowed. Which is not allowed, guys. Why it is not allowed? अगर मैं नोड 6 को 1 की वैल्यू दे दूं ना तो तुम गए काम से, क्योंकि इसका सबट्री सम क्या आ जाएगा? सबट्री सम क्या आ जाएगा? यहाँ 7 तक सम 3 था, अब 1 ऐड करोगे तो 4 हो जाएगा ना. 4 अलाउड नहीं है because 4 is already a subtree sum of some node in L2 chain. So you need to forcefully assign the node 6 the value of 2. Now it will look like 1, 3, 5. Now guys, can you see this L2 has come as sum, like L2 in the L2 chain the sums came as 2 and 4. In the L1 chain till here the subtree sums have come as 1, 3, 5. Now guys, node 5 you can assign any of the two values for node 5. You have assigned the value to node 9, node 10, node 6, node 7, node 8. Now my claim is node 4 and 5 any value can be assigned. Why? Node 5 pe if you put a value 1 or 2, now it does not matter. Now you can put two values. Why? Because node 5 is the part of L1 chain. If I add a 1, the 1, 3, 5 will look like 1, 3. The subtree sums of L1 chain are 1, 3, 5. Now if node number 5 I assign 1, the subtree sum of node 5 will be 6. So 1, 3, 5, 6 is also valid. And if I assign the value of 2 to node 5, the subtree sums of L1 chain will look like 1, 3, 5, 7. Both are allowed. Why? 6 and 7 both are allowed because 6 and 7 do not occur in the other chain. Other chain stopped at some 4. So guys, once the other chain has stopped now, the remaining chain you can just put two values here also, two values here also. Such an interesting problem. So यहाँ पर you had to forcefully add one value only one. Here you had to forcefully add one value two. Here also you have to forcefully add one value two. But these are the two nodes where you can add two values. So two contribution for this node, two contribution for this node, two into two, total four combinations possible. If you are trying to assign 1 to L1 and 2 to L2, done. This is the total number of ways, guys. Okay. So I want you to watch this video on repeat again and again. I know no one has explained like this to you before. Okay. So guys, this is the case we have discussed where the L1 chain is greater than equal to the L2 chain. Okay. L1 chain is greater than equal to L2 chain and we only हमने सिर्फ वही कॉन्फ़िगरेशंस की बात की है जिसमें हमने L1 पे we assigned L1 as 1 and we have assigned the leaf of L2 as 2. What if the reverse case? We have to count that separately. That's why this is such a nice, interesting problem. Really nice, really cute, really lovely. I really loved it personally. Like makes the tree concept and the combinatorics and the mathematical concept so clear to the person reading these things. So hopefully these things strike to you and you just enjoy. So now, guys, what about this X chain? Here you can always assign two values. Why? Because guys, this is a linear chain ना. Linear chain को पता है ना कुछ भी assign कर सकते हो. This is a linear chain. So here you can assign two values, one or two. Here also you can assign two values, one or two. Here also you can assign two values, one or two. So for this test case, what will be the final answer? Just let me show you. 1, 2, 3, and then it was like this, right? Right? So what I mean to say is that this is L1 chain, right? And this is L2 chain, right? So, and this is chain X. So whenever there are two leaves, let's say I'm trying to count the number of ways. Okay, type 1 ways, where this node is assigned as 1 and this node is assigned as 2. Both cannot be assigned 1 or 2. Then the subtree sum of these leaves will become equal. So this is assigned as 1 and this is assigned as 2. So let me write it like this. Now what I mean to say is then you know now what happened. Then you assigned 2 to this also. You assigned 2 to this also, right? 1, 2, 3. You assigned 2 to this also. So these two nodes fought with these three nodes. Okay. Fought with these three nodes. And here the fight got over. Why? Because this chain had the subtree sums of 1, 3, and 5. And this chain had the subtree sums of 2, 4. Now these two nodes are free. This is a free node. This is a free node. And this is also a free node. Here, free means you can assign two values for the first time. You can assign 1 and 2 both. Here also you can assign 1 and 2 both. Why? L2 chain का subtree sums क्या है? 2, 4 आ रहा है. L1 chain का subtree sums क्या आ रहा है? 1, 3, 5 आ रहा है. ये नोड पे अगर मैं 1 डालूंगा तो मेरा subtree sum दिखेगा 1, 3, 5, 6. इसी की जगह अगर मैं ये नोड पे वैल्यू 2 डालूंगा तो मेरा सबट्री सम दिखेगा 1, 3, 5, 7. दोनों ही चलेगा. क्यों? Why will both of them work? Because the subtree sum 6 and 7 is not interfering with any other sum. L2 दूसरे सम्स ये L2 से ही आ सकते थे, L2 तो 4 पे रुक गया, मैं तो 6-7 की बात कर रहा हूं. सो देर आर टू पॉसिबिलिटीज, 1356, 1357. और ये आने के बाद यहां पर भी तुम दो दो नंबर फ्रीली असाइन कर सकते हो. Let's say if I put here as 1 and I add it to 1356, will now look like 13567. And if I add here 2, it will look like 13568. And if I add here 1 with this configuration, 13578 or 13579, total 4 configurations, right? So मेरे कहने का मतलब ये है that if I combine all the configurations now, there are two ways for this node and there are two ways for this node also. So for node 4 there are two ways, for node 5 there are two ways. So how many free nodes are there? There are two free nodes, so the answer will be 2 raised to free. There are two free nodes, node 4, node 5. So 2 raised to 2, 4 ways are there. यहां पर एक या दो असाइन कर सकते हैं, यहां पर एक या दो असाइन कर सकते हो, टोटल 4 तरीके हो गए ना. नीचे के तरीके फिक्स्ड है, यहां पर 1 2 2 ही डालना पड़ेगा, इसके भी फिक्स्ड है, यहां पर 2 2 ही डालना पड़ेगा. So 4 ways, 2 raised to free multiplied by X chain, guys. Here also you are totally free. Once you have all these variations now the sum can only increase. यहाँ पर 1 डालो 2 डालो कोई फर्क ही नहीं पड़ता, because the sums can only increase, guys. No matter in which variation you are playing, beta, the sums can only increase. So here also you can put 1 or 2. Here also you can put 1 or 2. And here also you can put 1 or 2. This is very, very deep conditioning. Like not deep conditioning. This is a very deep concept. आपको समझना पड़ेगा कि एक बार दोनों चेन्स की लड़ाई खत्म हो गई तो जितने भी एक्स्ट्रा नोड्स है ना उन पे तुम कोई भी वैल्यू डालो, घंटा फर्क नहीं पड़ता. Like it really does not affect what you do, Ben. Because the 1-3, see the battle got over here only. When this became 135 and this chain subtree sums become 2-4 ना, and this subtree, this L2 chain ended ना. अब ये 5 के ऊपर मैं कुछ भी करूं मुझे कोई रोकने वाला नहीं, कोई रोक ही नहीं सकता, कुछ भी डालूं मैं. So this is also free, this is also free, and these are also free actually. You can call them as X. X is 3. So 2 raised to free dot 2 raised to X are the ways 1. And what will be ways 2? Well, I will show that to you later. And the final answer will be ways 1 plus ways 2. How to do that? The code implementation is given. Okay, you can check it out. If L1 is greater than equal to L2, you just need to make sure that यहाँ पर 3 लेंथ, मतलब जो भी छोटा लेंथ है ना, यहाँ पर 2 लेंथ है, तो ये 2 लेंथ यहाँ पर 2 + 1 3 को खाएगा, और जो बचे हुए नोड्स है सारे फ्री होंगे. Got it? So type 1 way is 2 into 2 raised to free dot 2 raised to X. What is type 2 ways? Guys, हमने सिर्फ वही तरीके गिने हैं जिसमें L1 चेन के लास्ट नोड को 1 असाइन किया था और L2 चेन के लास्ट नोड को 2 असाइन किया था. So ways 1 is clear, but what about ways 2? 1 2 3. What if I assign 1 to this and I assign 2 to this? Now what's going to happen? Well, this is your L1 chain, right? And well, this is your L2 chain, right? So in any configuration you assign anything, the nice thing is guys कि एक बार नीचे का डिसाइड हो गया और ऊपर सिंगल चेन है ना, तो कोई भी configuration होने दो, नीचे कुछ भी होने दो, ये सम 1 से बढ़ेगा, ये 2 से बढ़ेगा, 1 से बढ़ेगा 2 से, all the subtree sums will be unique only in that particular configuration. Try to make any configuration where you just assign single numbers, and you will see why for a linear chain you can always give two numbers without any worry, beta. Okay, is that clear to you? So what I mean to say is that if this is L1 chain and this is L2 chain and this is 2, this is 1, what will you do? 2 here, 1 here. So what can I assign here? Can I assign 1 here? No, because 1 plus 1 2, 2 is already there in the L1 chain, so I need to add a 2 here. Forcefully I will add a 2 here. So not 2, I mean the subtree sums will be 1 and 3 here. Here I cannot add 1 because 2 plus 1 will become 3 and 3 is already there. So I will just add a 2 here. So subtree sums are 2 and 4. And guys, the problem has ended. Why? Whichever chain has the smallest length, that has competed with the bigger chain till that length. इन दोनों का competition हो गया. It's over. Both are satisfied. Why? This guy, like the L1 chain subtree sums came out as 2 4. The L2 chain subtree sums came as 1 3. Now here if you put 1 or 2, the subtree sums will be what? 5 or 6, and 5 or 6 does not border 1 or 3. This chain has been over. Its maximum sum is 3. So yes, these are free nodes now. These are free nodes. This is also free. This is also free. And this X all free. So base 2 will be what? Well, base 2 will be 2 raised to free dot, like you can call it as free 2 count dot 2 raised to x again, where x is 3. So this time 3 free nodes came when you started assigning the L1 chain bottom leaf as 2 and L2 chain bottom leaf as 1. So base 2 plus base 1 is the answer. Done, done. Hopefully you liked it, guys. Love you all. So let me show you the implementation. I think you can go through it, guys. Very simple. You just do the DFS, BFS and try to find if it's linear or which type. Then you do the LC and the basic stuff. बहुत इजी है यार. अगर ट्री को सिंपली ट्रेवल भी करोगे तो पता चल जाएगा कि ये नोड, ऐसा नोड ढूंढना है ट्री में जिसके डिग्री 3 है. डिग्री 3 है, फिर देखो उसका पेरेंट कौन है. तो पेरेंट से अगर ऊपर जाओगे तो एक्स वाला चेन मिलेगा. और दो दो चाइल्ड है, फर्स्ट चाइल्ड से नीचे जाओगे तो L1 चेन मिलेगा, सेकंड चाइल्ड से नीचे जाओगे तो L2 चेन मिलेगा. कर लेना कैलकुलेट. डन 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 डन. राइट. Like if I try to show you the submission, if we have it, okay. Like how to calculate the answer for tree with exactly 2 leaves. For L1 chain, assign 1 and L2 chain assign 2. Like this is what you can do. Another thing is for L1 chain, you can just assign 2 and L1 chain, you can just assign 1. Job is done, done. And ways 1, the final answer will be what? Ways 1 plus ways 2. एंड यही दो तरीके पॉसिबल है. ऐसा नहीं हो सकता कि दोनों के एंड पे 2 या 1 लगा दो तो सबट्री सम रिपीट हो जाएगा ना. 1 1 2 2 2 बार. समझे बात को? सबट्री सम की बात कर रहा हूँ, नोड वैल्यूज की नहीं. बट लीफ का खास बात है कि जो लीफ का जो नोड का जो लीफ का जो नोड वैल्यू होता है वही उसका सबट्री सम होता है. इसलिए 2 लीफ तक चलेगा, 1 2 से ज्यादा नहीं बेटा. सो यू कैन सी हियर, सी I've written it here. Like then later on I did use a little bit of I think just to format this code, this two leaves, these might be written a little bit by AI. Anyways, now if L1 greater than equal to L2, you know the difference of both of them, then 2 raised to 3 dot 2 raised to x. And if L2 less than equal to L1, you just make all the cases, guys. I leave it up to you. I think you will be having the understanding. And that's, guys, see, ways 1 plus ways 2. P is the free nodes of the first assignment and P2 is the free nodes of the second assignment. Ram Ram. Ram Ram. If you need me, come to me. Okay, like if you want the daylight training and all the best things from me, you can always come to me. Okay, if you have the curiosity and the hunger to learn, you can come. Okay, so Ram Ram. More than the need, guys, the most important thing is the genuine curiosity and the hunger for learning. So do not give more importance to the previous statement of need, but give more importance to the curiosity and the hunger of learning. Ram Ram.
So, how many of you have participated in today's contest? Anshul, Suraj, Sri, Ajankya. How do you find the contest, guys? Was it easy? Was it moderate? Was it hard? It was a Div 3 actually. Okay, so it was moderate. So guys, okay, let's begin with the session. Okay. So let's begin with the very first problem. So the first problem is that Yusuf is at the entrance of a long halfway with n doors in a row, numbered from 1 to n. He needs to pass through all the doors from 1 to n in order of the numbering and reach the exit, pass door n. Okay. So each door can be opened or closed. If the door is open, so Yusuf passes through it in 1 second. If the door is closed, Yusuf can't pass through it. However, Yusuf has a special button which he can use at most once at any moment. This button makes all closed doors become open for X seconds. So task is to determine if Yusuf can pass through all the doors if he can use the button at most once. Okay, so let's take some example test cases for better understanding of the problem statement. So let's take these two. So I will be sharing my screen. Of course. Yes. Okay. Is my screen visible, guys? Is it visible now? Okay, it should be visible. Mukut, is it visible? Mukut, am I audible? Okay. So let's begin with the very first problem, guys. So let's begin with the very first problem. So this is the problem statement. So in this problem, so we have n doors. We have n doors in a row, numbered from 1 to n, and we want to pass through all the doors from 1 to n in order of the numbering and reach the exit. So okay, so we can pass a single door within 1 second. If the door is closed, if the door is open, if the door is open, if a door is open, then we can pass this door in 1 second. If this door is closed, then we cannot pass through the door. So we have a special button. We can use this button at most once at any moment. This button makes all the closed doors become open for X seconds. So now we are given this binary array where 0 is representing whether the ith door is open or closed. 0 is representing that the ith door is open and 1 is representing that the ith door is closed. So what we need to tell, we need to tell whether we can pass through all the doors or not. So let's see. So this is the test case. So this is the first. So yes, this is the very first test case, which is 0, 1, 0, 1, 0, 0, 1, 1, 0. So if I am, guys, when I will be using that button, then I will be using that button. For this test case, the length of the array was 4 and the x is 2. So guys, when you guys will be using that button will open the closed doors for x seconds. And in this particular case, this x is 2. It means the closed doors will be open for 2 seconds. So guys, you tell me, like we have read the problem statement, you tell me when you will be using that button. When you will be using that button. Mukut, Siri, Anshul, then you guys will be using that button. In terms of passing through all the gates, we will be using that button that will open the closed gates for X seconds. When door is closed, yes. Guys, we will be using that button. We will be using that button when I will be encounter the very first closed door. So, for example, if this is the case and here are some more open doors and I am currently standing here, then in this case, I will not be using that button because I can easily pass through this door because this door is already open. So same the case with this. When I will reach here, I will see this door is closed. Now, if I want to pass through this gate, then I have to use that button to open this door. So for at this particular moment, at this very index, at this particular door, I will be using that button, and that button will be opened for the X seconds only. So I need to once I use this button, I will be using this button from this index I. Now for I plus X, now from I plus X, all the closed doors will be open, guys. If there are another, let's say here are some additional doors that are closed, and this is I plus 1 index. So in this case, all the doors that are in range I to I plus X will be open, isn't it, guys? Isn't it? I will be using that button when I encounter the very first closed door, and whenever I use that button, it means all the doors from I to I plus X will be opened, no matter whether it is closed or open. Isn't it, guys? Isn't it? Shri, Mukut, is it clear? When I will be using the button, and after using that button, the upcoming X doors will be open. It doesn't matter whether they are already open or closed. So what I will be doing, I will be just calculating. Why don't we just calculate the difference between the very first and the last door? If the difference between the first closed door, the difference between first closed door and last closed door, if this difference is equal to X, then we can pass through all the doors. Otherwise, we will not be able to pass through the doors. Is it clear, guys? Is it clear? That was the very first problem. And all we need to check is just the difference between the very first and the very last closed door. And if this difference is less than or equal to X, then we can pass through all the doors. Otherwise, we will not be able to pass through all the doors. Is it clear, Mukut? Anshul? Should we move forward with the second problem? That problem was pretty easy. Let's see the implementation. So yes, here I am calculating the LO, which is the last door, and first door, which is the first operation. So FO will be containing the index of the very first one, and LO will be containing the index of the last one. And here I'm just calculating the difference. Obviously, I will be adding +1 because I have to include this I also. So from here to here, this will be X, but I have to include this I also. So that's why it's last minus first +1. If this is less than or equal to X, then yes, otherwise no. So that was about the first problem, guys. So let's move forward with the second problem. So this is the problem statement. A shrink operation on an array of size m is defined as follows. Choose an index I. So I is in range 2 to m-1 such that I has to be greater than I-1 and I+1. Remove AFI from the array. Define the score of a permutation P as the maximum number of times that you can perform the shrinkage operation on P. Okay, so you have given a single integer n, construct a permutation p of length n with the maximum possible score. If there are multiple answers, you can output any of them. So guys, let's proceed with the test cases. Let's proceed with the test cases. Okay, so let's say guys, we have n is equal to 3. This is the lowest n possible. So the for this answer is pretty obvious because we want that like the operation is performed on the index which is greater than the both of their adjacent index. So this 3 is actually greater than the previous and the next element. So I can remove this 3. It means I can perform this one operation, and after this operation the array will become 1 2. So for a permutation of size 3, I can perform this one operation. And this is the maximum number of operation I can perform on a permutation of length 3. So let's go with length 4. So guys, if I have this permutation 1, 2, 3, 4. So guys, can you find any index or any element in this particular permutation which is greater than both of its adjacent? Can you find any such element in this permutation? Yes, Divyam. We can use the button only once. Guys, my question is, can you find any element in this particular array which is greater than the adjacent of these elements, adjacent of their elements? Yes, there is no such element. So let's make it such that like 1, 3, 2, 4. Guys, what about this particular array? What about this particular array? 1, 3, 2, 4. What about this particular array? 1, 3, 2, 4. How many elements are there who are greater than both of its adjacent elements? 3. Right side. 3 is the only element which is greater than both of its adjacent. So I will be removing the 3. So I have removed the 3. Now the array will become 1, 2, and 4. But now this resulting array, which is 1, 2, 4, now you cannot perform the same operation again because now there is no such element which is greater than its adjacents. So if you choose to go with this permutation, you will end up being 0 operation. You will end up doing 0 operations. If you do this particular permutation, you will end up in 1 operation. Okay, let's see other possibilities for this case. Let's see this 1, 3, 4, 2. In this case, guys, 4 is the one which is greater than 3 and 2. So we will be removing the 4 and the resulting array will be 1, 3, and 2. And here I will be removing the 2 and the answer will be 1, 2. So here I can perform this one operation and this is the second operation. So if I choose this permutation, I will get 2 operations. I will get 2 operations. So I will be using this permutation because we cannot have better than this permutation. We don't have better permutation for the 4. Is it clear, guys? Is it clear? Mukut, Sahil, is it clear? Okay, so let's take another example. Let's take 5. Let's take 5. Let's take 5. So for 5, so guys, we have observed something. We have observed something that if we take this 1, 2, 3, 4, 5, so it won't make any sense because we want an element which is greater than both of its adjacent elements. So what we want something in middle. We want something in middle. So why don't we swap 3 with 2? 1, 3, 2. And then we will be swapping this 4 with 5, then 5 and 4. Guys, what about this case? We will be swapping uh, 2 with 3 and 4 with 5. Then we will have 1, 3, 2 and 5, 4. In this case, in this case, you can remove this 3 and you will get 1, 2, 5 and 4. And then you will remove this 5. You will get 1, 2 and 4. And you will be able to perform two operations. You will be able to perform, this is the first operation and this is the second operation. Can we do it better? Can we have a better permutation, guys? Can we have a better permutation? Guys, I can see that if I choose this permutation, then I am end up in 3 remaining elements. But the best permutation would be that will end up in only 2 elements. Isn't it? Isn't it? Isn't it? Guys, here what I can see is this particular permutation is end up in 3 elements, and we have seen that the better solution would be if the permutations end up in only 2 elements, isn't it? Because 1, 3, 4, 2 end up in only 2 elements, and I can see that if somehow we have made this permutation in such a way that we end up in only 2 elements. Is it possible, guys? Is it possible? Mukut, Sahil? Siri? In terms of maximizing the number of operations, why don't we choose a permutation such that after the number of operations, the remaining elements in the array will be only 2? Because now because when you have an array of length 2, now you cannot perform further operations. Because to perform that operation, the size of the array has to be at least 3. Isn't it, Mukut? Okay, so we have understood this. So now you guys tell me that how should I arrange this permutation of 1, 2, 3, 4, 5 such that I will end up in only 2 elements in the array after all the operations. Because you can see the size of this array is 3. Size of this array is 5, and the remaining element in the array will be 2. So it means the number of operations can be done is 3. It means I can perform at most 3 number of operations. But the question is how you will be arranging this permutation such that you will end up in 3 number of operations. You will end up in 3 number of operations. So let's see. So guys, first of all, I want an element which is greater than its adjacent. It's both is previous and the next value. So why don't I take 5 for we are solving this for 5, and I take 5 and I will take this 4 here and 3 here. It means now this 5 is greater than 4 and 3, and now I will take 2 and 1. So it is like a pyramid structure, guys. So let's perform operation here. Like I will be removing this 5, then I will have 2, 4, 3, 1. Again, this pyramid structure is preserved. Then I will be removing this 4. Then I will have 2, 3, and 1. Again, this pyramid structure. Then I will be removing this 3. And then I will have 2 and 1. So what we have understood is that we will be keeping this pyramid structure after every operation, and we supposed to keep the maximum element to the center and the second largest element to its left or right, and then the third largest element to the right if the if you have chosen second left to put like this is a sort of zigzag pattern, like this 5, then 4, then 3, then 2 and 1. Like this pattern could be this 5, 4, 3, 2, 1. This is also possible, because here we are also preserving the pyramid structure. So in that way, we can ensure that n minus 2 number of operations can be performed. If we have this pyramid structure, which can be obtained by the zigzag pattern of like this is n, then we can have n minus 1 here, then n minus 2 here, then n minus 3 here, then n minus 4 here. And every time you will be removing the central element. If it is odd and if it is even, then the uh, like if there will be two central elements, then you will be removing the first central element. So if you choose to put the element in zigzag manner, then you will be ensuring that there will be n minus 2 number of operations, which is the maximum number of operations that can be performed on the permutation of length n. Is it clear, Mukut? Mukut, is it clear? Shri, Sahil, Anshul, is it clear, guys? So that was about this problem. The simple observation is this, that if we want to remove an element which is greater than both of its adjacent, then why don't we put the maximum element to the center and then the second minimum to its left or right, like it can be here 4, let's say 4, and then 3 here, then 2 here, then 1 here. Because after removal of this 4, then again this 4, after removal of this 5, then again 4 will be again greater than both of its adjacents. And after removing this 4, 3 will be again greater than both of its adjacents. So it is as simple as that. So there are two possibilities. You can put the next element, like there is this 5, 4, 3, 2, 1, this possibility as well. So all you need is to just print numbers 1 to n in zigzag manner. So let's see the code, guys. So here we have this answer array, and the position of the greatest element would be this n minus 1 by 2. And then we have a right position, the position of the second largest element, that would be left plus 1. So the current element is n, and place left is true. So guys, this is a simple implementation. Here I will be looping until the current element is greater than or equal to 1. So if place left is true, then answer of left will be equal to current minus minus. It means I will be placing the current element to the left place, which is n minus 2, and then I will be reducing the current value by 1 and the position of the current element by 1. If this is not the case, then I will be placing the current element to the right, and in both of this case I will be reducing the value of the current element by 1. But all you need is just to maintain this zigzag motion, so this left minus minus and right plus plus. So that's why here I'm doing right plus plus. So that's why we have these two pointers, left and right. So left will be going from here to here, and right will be going from here to here. So this is the implementation. Like, this is not the only implementation possible. Like, there are several other implementations for printing the zigzag array. Like, this is the one possible one. You can try in your own manner, but the whole logic is to understand this, why this zigzag pattern will work, and this is the only thing that we need to see in terms of solving this problem B. Is it clear? Is it clear? Because Anshul, what if the number of elements are even? How are we supposed to take the largest element in the middle? Like, you can take the largest element if you have the 6. Let's take this example. If you have the 6, so you can have this 6 here. I mean, it's totally up to you how you choose to put the second largest element. 6. If you choose to put the second largest element on the left, then the 6, 5, 4, 3, 2, 1. If you choose to put the second largest element to the left, then the position of the largest element will become 0, 1, 2, 3, 4, 5, which is n by 2. And if you choose to put the second largest element to the right, which is 6, 5, 4, 3, 2, 1, then the position of the largest element will become n minus 1 by 2. So it's totally up to you how you choose to put your largest element. If you have even number, you can put the largest element, because if the size is even, then there will be two middle elements. So now it's your call whether you will be putting the largest element on the first middle element or the second middle element, and in that manner you will be implementing your algorithm. So that is totally up to you. Is it clear, Harith? Harith, is it clear what we will be doing? Shivam, is it clear? Is it clear, Shivam? Okay, so guys, let's move with the third problem, which is the C1. Okay, so that problem was good. That problem was good. Yes, as you can see the tag here, it is greedy. So you guys already got the spoiler. So let's understand the problem statement. We have an array A of size n. So a partition is called Goad if every segment Bj, all elements in Bj also appears in Bj plus 1, which is the upcoming partition, if it exists. That is, every element in segment must also be present in the segment following it. So guys, we have an array A, and we will be partitioning the array into multiple segments, but the segments will be consecutive. And we will be seeing that the ith segment, the number of elements that are present in the ith segment, has to be in the next segment, or the I plus 1 segment. So for better understanding, let's take few test cases. So let's take these 3 test cases. Okay, let's take these 3 test cases. Okay, so the very first test case is 1, 2, 2, 3, 1, 3. Okay. So 1, 2, 2, 3, 1, 5. So guys, let's see how you will be approaching this problem and when you will be making the partition. So let's take, we have this one, okay, these 2, okay. Okay, so this 1, 2 I can see here, and there is also 1, 2. So I mean, this is the first partition, and the next partition has all the elements which are there in the first partition. So we can enlarge this partition to this. So this is one possibility. This is one possibility, guys, that your first partition is 1, 2, and your next partition is 2, 3, 1, 5. So all the elements which are present in your first partition are also in the second partition. So there are the maximum number of partition that we can achieve is 2 only. Okay, guys, is there any other possibility? Is there any other possibilities? So let's take, we have this one only in first partition, and in second partition we can have 2, 2, 3, 1, 5. This is also another possibility. Do we have any other possibility, guys, other than these 2 possibilities for the very first test case? Mukut, Shivam, do we have any other possibility, any other number of partitions other than these 2? Think and tell. Because if you increase the very first partition with this 1 to 2, 1, 2, 2, this is 2 guys, 3, 1, 5. So as you can see, all the elements which is 1 and 2, 1 is there, but 2 is not there in this partition. So this will not be a valid partitioning. So that's why we can conclude that these 2 are the only possible partitioning. Yes, 1, 2, and 2, 3, 1, 5. Yes, we have already encountered this partitioning, which is here only, which is 1, 2, and 2, 3, 1, 5. And the second partitioning that is possible, which is 1 and 2, 2, 3, 1, 5. Both are giving the same result, which is 2. Is it clear, Mukut? Shivam? Is it clear? Okay. So let's take the second test case. So second test case. So 1, 2, 1, 3, 2, 1, 3, 2. Guys, if you want to maximize the number of partitions, then why don't I choose my first partition to be as minimum as possible? Isn't it? What we want to maximize the number of partitions. We want to maximize the number of segments that make a cool partition. Isn't it? Make the first element the first partition segment. That is very clever observation, and at the same time it is very obvious, because what we want to maximize the number of segments. In order to maximize the number of segments, then why don't I choose my very first segment to be as minimum as possible? So that's why Anshul came up with the idea that if I want to maximize the number of segments, then why don't I choose the first segment to be the very first element only? Because now I have first partition, which is the very first element, and now see, the second partition will be this only. Because now I have to check only one element in the second partition. Because guys, you see, in this particular scenario, I have to check 1 as well as 2 in the second partition. But in this case, all I need to check is 1, whether 1 is there in the second partition or not. So that will make our work easy. And it will also increase the possibility of maximizing the number of segments. So let's begin with this test case. And here we will be taking the very first element as the first segment. And now 2 and 1. Okay, now I am done. I have found the till here. I will be searching, okay, 2, whether I have found all the elements which are present in the first segment. No. Then I will be adding 1 into the segment. Now I will check whether I have found all the elements which are in the previous segment. Yes. Okay, so now I am done with the second segment. Now I will begin with this. Okay, 3. Okay, 3 is not in my first segment. Now, not in my previous segment. Okay, 2. Okay, now I am done with 2. And then 1. Okay, now I am done with 1 as well. Now I am done with the third partition. So let's begin with the 4. 3. Okay, I have found the 3. 2. I have found the 2. 1. No. I haven't found the 1 yet. So it means there are 3 complete segments. So for this particular test case, answer is 3. And for this particular test case, answer was 2. So let's take other interesting examples. Let's take this fourth one. Okay. So in fourth one, 5, 8, 7, 5, 8, 5, 7, 8, 10, and 9. So very first partitioning would be the very first element. Then I will be searching 8. Okay, no, I am not done yet. 7, no, 5. Yes, 5 was there in my first segment. So yes, I have visited the 5. And I am done with the second partitioning. Guys, you tell me whether it would be optimal to continue the partition even when you are done with all the elements which are present in the previous uh, partition. Guys, here whether isn't it optimal to stop this partition at this 5 only? Because in order to maximize the number of partition, I can see, and it is very intuitive, that we should stop this partition here. There is no point in continuing this partition because I have found all the elements which are present in the previous partition in the current partition. It means I can stop the current partition here only. Is it clear, Mukut? Is it clear? Anshul, Mukut, is it clear? Yes. So there is no point in continuing the partition once you have seen all the elements which are there in previous partition in your current partition. So now let's begin with the third partition, which would start from 8. Okay, 8. Okay, 8 I have visited. 5, yes, 5 was there in my previous. 7, yes, 7 was also there. Okay, again, here I am done. Here I am done. Here I have seen all the values which was in the previous partition. So now again the fourth partition will begin from here. 8, okay, yes, 8. 10, no. 9, no. Okay, so there were 3 partitions only. Okay, so we have understood the idea. Now the question is the implementation. How we will be implementing this? The question is implementation. How we will be implementing this? But first, guys, just confirm whether this idea is clear or not. Okay, so this idea is clear. Okay, we have approach from Anshul side. Maintain 2 sets, one from the previous segment and one for current segment. Okay, if we encounter an element that is present in previous segment, we can remove it from previous segment set. Once previous segment set is empty, we found a new valid segment. That is a very correct implementation. Let's see if Anshul idea is correct. Let's see. Anshul has come up with the very clever approach, and which will be implementing this idea with the 2 sets. We will be using this particular test case, which is this 5, 8, 7, 5, 8, 7, 5, 8, 5, 7, 8, 10, 9. Okay, so we will be using 2 sets. Let's say set 1 and set 2. Set 1. In this set 1, we will be having 5 only, and then we will have set 2, and set 2 is initially empty. And now we will be begin with the second element, because we already know the first element is the part of the first partition. Then there is no point in traversing the first element. So we will start traversing from the second element. So okay, 8 is 8 the part of the first segment? No, 8 is not part of the first segment. So we will be adding 8. So we will be adding 8 to the second segment. 7 is not again the part of the first segment. So we will be adding 7 to the second set. 5, yes, 5 is the part of the first segment. So we will be adding 5 to the set 2 again. And we will be removing this 5 from set 1. Once the set 1 is empty, you guys are done with your second partition. So now counter plus plus, because set 1 is empty, so counter plus plus. So counter will become 1. Counter will become 2, because there will be one partition, obviously. So once you are done with the first partition, so you are done with the second partition, because in the first partition there was an element which was the first element. So now we are done with this. So why don't we swap this? Now this will become set 2, and this will become set 1. Again, the same algorithm. Then now the algorithm will proceed again the same way. 8. Okay, 8 will be entered in the set 2, which is the second segment. So guys, this would be the current segment and this is the next segment. According to Anshul's approach, this would be your next set and this is your current set. Like it's a naming, it's a sort of naming convention. You can name your sets in whichever way you want. So I am currently at 8. So 8 will be added to the second set and 8 is in the first set. So we will be removing 8 from the first set. Now this 5, we will be adding 5 to the current set and we will be removing 5 from the set 1. Okay, yeah, set 1 because 5 is there in set 1. And then we will be moving to the 7 and we will be inserting 7 here and we will be removing 7 from here. Now the set 1 is empty. Whenever I see set 1 is empty, I will be increasing the counter. Now counter will become 3. Now counter will become 3 and this set 1 and set 2 will be swapped. So this is set 2. So this is set 1, this is set 2. Okay, so now I am at 8. Okay, so 8 will be added to the set 2 and 8 will be removed from the set 1. Then I am at 10. So 10 will be added to set 2, but 10 is not in set 1, so I will not be removing the 10. So again 9 will be added to the set 2. So again, as you can see, set 1 is not empty, so we will not be increasing the counter and we are done with traversing whole array. And we have the counter which is 3, which is the answer of the test case. So guys, is it clear that how we will be using the two sets approach in terms of implementing that approach, the algorithm that we have understood? Is it clear, Mukut? Anshul, yeah, of course, Anshul has proposed this idea, so it should be clear. So we have already, can you please dry run it? Okay, so we have this 1, 4, 3. Here we have the 1, 4, 3. Okay, so let's see. So in set 1, we have 1 and set 2 is empty. So we will begin with the very second element, which is 4. 4 will be inserted to the second segment and we don't have 1 here. Then we will begin with the third element. Then we will be inserting the third one, then the fourth one, then the fifth, then the third, then the fourth, and then the 1. So 1 I have seen here, and then I will be removing 1 from this set. Now my set 1 is empty, it means counter will be increased. So counter value will become 2. So for this particular test case, the answer will be 2. Isn't it? Isn't it, Harith? Is it clear that for your test case answer will be 2? One, 4, 3, 4. How is it possible? 1, 4, 3, 4. It cannot possible. Like you are doing segmentation like 1 and then 4. Your second segment has not all the elements which are in first one. This is not valid partitioning. This segment has to be all the elements which are in the previous segment. So this will not be a valid partitioning. Is it clear, Harith? Okay, so let's move with the implementation that we have seen already. So we will be maintaining two sets, set 1 and set 2. Like you can name them previous or current. So I am inserting the value in the current set, and if I encounter the same value in the set 2, then I will be erasing that value from the set 2. Because guys, I have initialized the first partition as a set 2. Like the very first partition, which would be the very first element that I have inserted in set 2. You guys can also insert it into set 1 or previous set or your current set. It's totally up to you. So if I encounter the value in the second set, or the previous set, then I will be removing this set. And whenever I see the set is empty, then I will be incrementing the answer and I will be swapping the sets S1 and S2. As simple as that. This algorithm will be iterating from the second element or the first, like I have it initialize the indexing from the zero, and then in return I will be just printing the answer. So it's totally the implementation stuff. It's totally up to you how you choose to implement this problem. Like it could be way more complicated than this, but this is the very easy version of using this set one and set two. You guys can use previous set and current set. So it's totally up to you. You guys should try to implement this. That will actually give you the experience and the idea to solve this problem. But we are done with the algorithm, and it's now totally up to you how you choose to solve this problem with these two sets and how you do the if and else condition. It's totally up to you. Is it clear, guys? Should we move forward with the fourth one? Should we move forward with the fourth one, guys? Harith, Anshul. Okay, so let's see the fourth one, guys. So we have an array A1, A2 to AFN of n elements, and an array gets exploded when all of its elements become equal to 0. Okay, in one operation, Yusuf can do exactly one of the following. For every index I in A of I, decrease A of I by 1. For every index I in A, decrease A of I by n minus A of I plus 1. Okay, so we can decrease either by I or the n minus I plus 1. Either by this quantity which is I or n minus I plus 1. Okay, your task is to help Yusuf determine if it is possible to explode the array using any number of operations. So exploding the array means making all the elements equal to 0. And we can do any number of operations. Okay. So let's take the test cases. Let's take these test cases. Let's take these cases, guys. Okay. So on the ith one, we have seen either we can decrease A of I by I, or we can decrease A of I by n minus I plus 1. Isn't it, guys? N minus I plus 1, yes. Isn't it? Okay. So we have this two possibilities. And what we want to make the array, all the elements of the array equal to 0. So we have this 3, 6, 6, 3, and we want to make them equal to 0, 0, 0, 0. So let's see. So this is the very first, second, this is the third, and this is the fourth. So guys, you tell me. So I will be like, for each index I, A decrease A of I by this. Okay, so we supposed to perform this operation on whole array, because we supposed to do exactly one of the following. For every index I, A decrease A of I by I. Okay, so like this operation will be performing on the whole array, and either we can decrease this whole array with this quantity 1, 2, 3, 4, or the quantity 4, 3, 2, 1. Isn't it, guys? Either we can decrease this whole array, or we will be subtracting this whole array by 1, 2, 3, 4, or by 4, 3, 2, 1. Isn't it? Isn't it, guys? Mukut, Ashish. Okay. So we will be decreasing this whole array with this quantity. Okay, so as we can see that this 4, whenever I will be subtracting this 4 with this 3, then the output would be -1. Because if I subtract this 4 or either this 4 with this 3, then output would be -1. So it means I will never reach to 0. If I perform at least one operation on this array, then I will end up in -1 on the first or the last position. So it means for this test case answer would be no. So let's see the second test case, which is 21, 18, 15, 12, 9. So as you can see, the common difference is 3. So this common difference is 3. And we will be 1, 2, 3, 4, and 5. We can either subtract this whole array with this quantity or this quantity, which is 1, 2, 3, 4, 5. And we have seen this common difference, which is equal to 3. So how we will be proceeding? How we will be proceeding is, okay. So guys, like we can think in this direction how a valid array would be constructed. Let's think in reverse direction. How, like we will not be thinking like from an array A to all zeros. We will be thinking from all zeros to an valid array A. If you have all the elements which are equal to 0, 0, 0, 0, 0, 0, either you will be adding 1, 2, 3, 4, 5, 6, 7, 8, and so on, or 8, 7, 6, 5, 4, 3, 2, 1. Like either you will be adding this array to this whole 0, or you will be adding this to this whole 0. Isn't it? In terms of forming a valid array, we will be either adding, let's take the array of length 8. You will be either adding this to this 0 array or this to this array. Now it depends like how many times you can add this whole array by X amount and this whole array by Y amount to this 0. Then you will be end up getting a valid array. Isn't it, guys? Is it clear? Mukut, is it clear? Ashish, Anshul, is it clear? Abhishek? Okay, so this thing is clear that in terms of creating a valid array, we will be adding this 1 to n and this n to 1 array into x time or y time. So it means the ith position. So a of I. So we are talking about a valid array. In terms of a valid array, a of I will be equal to x into I plus y into n minus I plus 1. Isn't it, guys? If the array is valid, then for all I, this condition should be satisfied. Is it clear, guys? Is it clear? Mukut, Ashish, Anshul? Is it clear? This equation should be clear. Okay. If this equation is clear, that for every a of I, like a of I will be equal to xi plus y into n minus I plus 1. So guys, let's take summation of this array, summation of I from 1 to n. So this will be also summation. I is going from 1 to n. So x I am taking common, and here I have I. So summation of I, which is 1 to n, plus here I am taking y common because y is constant. Then summation of n minus I plus 1, I1 to n. So guys, this whole thing and this whole thing is nothing but 1 plus 2 plus 3 up to n, and this thing is nothing but n plus n minus 1, n minus 2 up to 3 to 1. Is it clear guys? This x into this is the summation of n natural numbers, and y into this is nothing but a summation of n natural numbers. Is it clear guys? Mukund, Anshul? Okay. So this thing is clear to us. It means that the summation of the whole array, summation of a of I goes from 1 to n, is nothing but the summation of n elements, which is n into n plus 1 by 2. So guys, we know already this 1 plus 2 plus 3 up to n. This is equals to n into n plus 1 by 2. This is the basic maths. This thing into x plus y. So this is the very first equation that we have. Is it clear guys? Is it clear? Harit, Mukut, Anshul, is it clear? Is it clear? So n is given to us. Summation of the array is given to us. Like we can calculate the summation of the array. So let's say take it the sum s divided by n into n plus 1 by 2, which will be equal to x plus y. Okay, so this is the first equation. So guys, we have this x and y, and we have seen that each a of I will be in the form of xi plus y into n minus I plus 1. So I just need to find the value of x and y, and I will be checking for each I whether this thing is satisfying or not. Like this thing has to satisfy for all I. Like this x and y will be constant. I will be keeping x and y as constant, and we will be checking for each I. If this thing is satisfied, then the answer would be yes, else the answer would be no. And we have seen the reasoning that why so, because if initially we have because how a valid array will look like, the valid array will have I will be adding this particular thing to the zero array or this particular thing to the zero array. So the ith term in the array will look like this. All we want is just x and y, because this x and y will be constant for all I, because we are adding x times this and y times this, and this will give us the valid array. So we have seen the reasoning, and we have concluded this equation, which has two unknowns x and y, and we want to compute this x and y. Guys, we have another equation. What would you say about a of 1? Guys, a of 1 will be x into 1 plus y into n minus 1 plus 1. So it means a of 1 will be equal to x plus n into y. So this is the second equation. Is it clear guys? Is it clear Anshul, Harit, Ashish, Mukut? That we have two equations. First equation is x plus y, which is equal to which was equal to the summation of the whole array, divided by n into n plus 1 by 2. And the second equation. This is the first equation, this is the second equation. And now you have two equations and you have two unknowns. You will be finding the values of x and y. And the values of x and y has to be positive, non-zero. Like the values of x and y has to be positive or non-zero values. And you will be validating this particular thing. You have x and y, and you will be iterating I from 1 to n. You will be checking whether all a of I, all the elements of the array are satisfying this equation, this particular thing or not. And how you will be getting the x and y? You will be getting x and y from these two equations. Is it clear, guys? Ashish, Harith, Mukut, Anshul, is it clear? Please respond, guys. So yes, that was about the fourth problem, and I want you guys to come up with the solution. We are done with the logic. And I am not proceeding with the implementation because all you need is just to find the values of x and y. You have two unknowns, two variable, and now it's completely your call how you will be implementing the problem. We are done with the algorithm. I will be providing the C++, Java, and Python version or the pseudo code. Like we have done with the algorithm in the doc, but for now, it's already 12:40 actually. So we are done with the first four problem of Div3, and I hope you must have understood all the four problem and you must have enjoyed all the four problem. So guys, that was about today's session. Thank you. Good night.